Okay, we are given this diagram, two different diagrams, and we are asked, are the sides of the quadrilaterals inscribed in the two triangles congruent? So the two quadrilaterals are square and rhombus. So before the answer, okay, let me just say the answer before we analyze. The answer is yes. So I will start by analyzing each of them. So we start with the square. A square is inscribed in a triangle given, and since it's a square, such that if you notice the sides are on the given side of the triangle. Likewise, if you check the two triangles, the sides of the square, the two sides lie on the sides given. Though indirectly we are given this, so let's just go back. So since the two quadrilaterals are parallelograms, that is, the two sides are opposite sides are parallel, so we add some things on the diagram. So the first thing, since this is a square, means that each interior angle is 90. So this is automatically a right angle triangle. And if we call the length of the side x, here is x, all the sides are congruent. So remember, the sides are parallel. This is parallel to that. It's parallel to this. So making this angle to be 90 by corresponding angle theorem. And since the total length here is a, we have a minus x, the remaining length, that's from here to here. Why this is x? Say that triangle EBC is similar to triangle, the bigger one, EAF, which implies that the ratio of the corresponding side must be proportional. So this a minus x corresponds to a in the bigger triangle, while this side x corresponds to b. So with this, let's solve for x. We have a over a is 1 minus x over a equals x over b. This is 1. This crosses over to be x over a plus x over b. And looking at this, they have common term, which is x. We bring it out, 1 over a plus 1 over b is 1. And the LCM here, they are solving for this. We have a plus b is 1. So making x the subject of formula, x is now ab over a plus b. So whenever a square is inscribed in a triangle, the length of the side is just the product, the side given, the side on which the two of the sides of the square lies on. So that's it, that's the formula. So let's go over to the rhombus. Okay, we're on the rhombus now. The same way, if we call the sides maybe y, the remaining side here is r minus y, because the total length is r. So using similar triangle theorem, we see that triangle PQR is similar to triangle PXT, which implies that the ratio of the corresponding sides, so we have r minus y over r. So this small triangle corresponds, that's r minus y corresponds to r in the bigger one, equals the length here, which is y over p, the total length here, p. So let's solve for y. So that same way, that same thing, this is 1 minus y over r. Why this is y over p. This crosses over to be plus, so y over r plus y over p. And if we factor y, we have y 1 over r plus 1 over p. So which is y, the LCM is rp, so p plus r. Remember this one. So if you solve for y, therefore y is rp over p plus r. So no matter the configuration, if r is here, yp is there, they would give the same result. So what do you now notice? Coming to the original diagram, they are the same because the sides on which the two side of the inscribed quadrilateral lies on the sides given. Check the first diagram. For x, this is a and this is b, and the side lies on a and b, the two sides. The same way, this is r and this is p. Two sides lies on the sides given, and from our equation here, the sides given happens to be the same. Yes, because this is a right triangle, meaning that the remaining side is 3 cm. So if you compare 3, 4, here is also 4, 3, they are the same. So the side will give us the same thing because we call this x and we call this y. We've solved that x is 3 times 4 over 3 plus 4, which is 12 over 7. The same way, we'll solve that y is 4 times 3 over 4 plus 3, which is the same as 12 over 7. So our answer is A. Yes, our answer is option A.